Hello students, and welcome to our channel CA Made Easy. Take a deep breath, settle down, and get those notebooks ready. Today we are stepping right back into the training ground for part 2 of our Mathematics of Finance Explainer. Now if you remember our last session, we built our foundation, right? But today, today we're going to learn the actual techniques that make money grow in the real world. So let's focus and let's begin. Here is our roadmap for today's training session. We'll start with a quick welcome to part 2, then dive into the compound interest kafanda. After that, we'll unlock the master formula, explain conversion periods, reveal some very cool ninja calculator tricks, and finally conquer some real ICAI problems. Alright, kicking things off with section 1. Welcome to part 2, where we level up from simple interest. So in our previous class, we completely mastered simple interest. But let me tell you students, simple interest was literally just our base form. Notice the huge contrast here. With simple interest, your principal remains totally constant throughout the entire period. It is just flat. If you invest 100 rupees, you just keep getting interest on that original 100 rupees year after year. It's like a basic attack. But under compound interest, we go Super Saiyan. The principal goes on changing and increasing at the end of specified periods. Your growth scales exponentially because you actually start earning interest on your previously earned interest. Moving right into section 2, compound interest kafanda, the logic of exponential growth.
तो चलिए समझते हैं इसका फंडा. Let's really understand the logic behind this exponential growth using a real-world scenario straight from your ICAI textbook. ध्यान से सुनिए. Suppose you walk right into an ICICI bank. You deposit a principal amount of 50,000 rupees for a duration of 2 years, and the bank offers you an interest rate of 7% per annum compounded annually. Now, if this was our old base form simple interest, 7% of 50,000 for 2 years would give you exactly 7,000 rupees. But because this is compounded, the bank calculates your first year's interest, adds it directly to your 50,000, and for the second year, your principal is suddenly much larger. Because of this ever-growing base, your total compound interest earned becomes 7,245 rupees.
Look at this number, 245 rupees. I really want you to emphasize this number in your mind. This is your power multiplier. This is the extra wealth generated purely out of thin air because of the magic of compounding. It's the excess interest generated specifically because the principal for your second year was greater than your first year. Your wealth is literally multiplying. Ekdam clear hai? This right here is why compound interest is the absolute ultimate technique in finance. Next up is section 3, the master formula. It's time to unlock the ultimate spell. So, how do we calculate this without taking hours to just do it year by year? Well, we need a master formula. I want you to write this down in bold letters. AN equals P multiplied by 1 plus I raised to the power of N. Let's break down each component patiently because this is absolutely crucial. AN is your accrued or accumulated amount. That's your final powered up total. P is the principal amount you started with. Now be very careful here. I is not just the annual rate. It is the rate of interest per conversion period written as a decimal. And N is not just years. It is the total number of conversion periods. Trust me, if you truly master what I and N represent, no exam question can defeat you. Let's dive into section 4. Conversion periods explained. These are basically your training intervals for maximum power. You see, compounding doesn't always happen just once a year. Banks use conversion periods. Think of them as your training intervals for maximum growth. Read through this table with me. A conversion period is simply the interval at which your interest is calculated and then added to your principal. If a bank says compounded semi-annually, that means every 6 months. So in one single year, you have 2 conversion periods. Your N for 1 year becomes 2. But wait, since you're compounding twice as often, your annual interest rate gets divided by 2 to find your I. If it's quarterly, N multiplies by 4 and your rate divides by 4. It's kind of like entering a hyperbolic time chamber. You're getting way more compounding sessions in the exact same amount of time, rapidly leveling up your frequency. Now for section 5, ninja calculator tricks. This is all about speed and accuracy for the exam. Understanding the formula is fantastic, but let's be real. In the exam hall, that clock is ticking. You need speed and you definitely need accuracy. The ICAI module explicitly notes that computations should be quite simple with a calculator. So let me teach you a ninja calculator trick. Step 1. Always lock down your N and I first. No mistakes here. Step 2. On your calculator, just add 1 to your decimal rate I. Let's take example 12 from your text. 2000 rupees at 10% annually for 2 years. Your I is 0.10. So just type 1.1 on your screen. Step 3. To find the power of n, if n is 2, you just multiply 1.1 by 1.1. You get 1.21. That is your compounding factor. Progressive multiplication makes this insanely fast. Step 4. Simply multiply that 1.21 by your principal of 2000. Boom! 2420 rupees. बहुत simple है ना? Practice this movement until it just becomes pure muscle memory. Finally, we reach section 6, solving ICAI problems. It's time for our boss battle with example 19. All right, students, stretch your fingers. It is battle time. We're going to apply our master formula and our new calculator skills to a real high-level ICAI example problem. This is example 19 from your module. Now, instead of finding the final amount, we actually have to find the missing principal. Let's see if our training holds up. Here are the stats for our challenge. The accumulated amount, AN, is already given to us, 78,030 rupees. The interest rate is 4% per annum, the compounding frequency is semi-annually, and the time is at the end of 1 year. Our mission, find P, the original sum invested. I want you to mentally pause right now. Don't look ahead. What will your N be and what will your I be? Remember our training. Semi-annually changes the rules of the game. Okay, let's execute the steps together. Step 1. Because it's semi-annual for 1 year, your periods n equals 1 year multiplied by 2, so n is 2. Step 2. Your rate I is 4% divided by 2, which gives you 2%, or 0.02 in decimal form. Step 3. We set up the master formula. 78,030 equals p multiplied by 1.02 to the power of 2. Step 4. Time for your calculator trick. 1.02 squared is 1.0404. Now, just divide 78,030 by 1.0404, and there it is. P equals 75,000 rupees. Challenge completed. You just successfully tracked backward to find the initial sum. Shabash! As we wrap up today's session, I want to leave you with a really thought-provoking question to test your new power levels. Read this carefully. If money doubles in a certain time at compound interest, how long will it take to quadruple? Think about the exponential curve we discussed today. Think about how compound interest works on itself. Try to work this out in your notebooks. You guys have done excellently today. Keep practicing these steps, truly master those calculator techniques, and I will see you in the next class. Keep practicing, future CAs.